Hi, my name is Jason Freeman. I'm professor and chair of the School of Music at Georgia Tech, and I'm here with the fourth video in my series on learning sound synthesis with VCV Rack. As you probably know by now, Georgia Tech School of Music is an awesome place. We have bachelor's, master's, and doctoral degrees in music technology. We conduct groundbreaking, innovative research in music technology, and we offer opportunities in music for all Georgia Tech students. You can learn more by visiting music.gatech.edu or watching the final video in this series to learn more. In this video, we're going to build on what we did when we learned about envelopes and LFOs in the last video and look at another way to change sounds over time using a step sequencer to create a loop of musical events. We'll also look at the concept of quantization and how we can use that to make sure that events happen at structured points in time according to a common pulse or meter, and also how we can tune frequencies to the notes of a scale. In the last video, again, we looked at envelopes as compared to LFOs and the different roles that they play in changing sounds over time. Envelopes, as you may remember, happen once per note. They start when I push the key down to start playing a note, and they do their final release when I let go of a key to end a note. Low frequency oscillators, or LFOs on the other hand, repeat forever. They're always wiggling back and forth with some kind of basic waveform to change something like the frequency of a sound to create a vibrato effect or something along those lines. Both of these, though, are typically continuous changes. So they don't jump around very suddenly, but they usually ramp very smoothly from one value to the next to the next. Sequencers, and particularly the step sequencers that we're going to be looking at in this video, are different. They also change things over time. They run in a loop, just like a low frequency oscillator runs in a loop. But the changes are discrete. They happen very suddenly in little bursts every beat. And so we have a series of pulses and a metronome that's keeping track of those pulses. And every time we get to a new beat, a new step in our sequencer, a new set of values are sent out to suddenly change what's going on. If you look at the step sequencer here, you'll see there are 8 steps, 1, 2, 3, 4, 5, 6, 7, 8. And each of those steps has 3 knobs connected to it. And so whenever we hit one of these steps, it sends out these 3 new values. Let me show you what I mean. Here we are in Rack. I've got our regular default patch open. I'm going to go ahead and add a step sequencer to it. I'll push enter in an empty spot, make sure I'm on the VCV section here, and drag the seek-3 object onto my rack. I'm going to also go ahead and get rid of this MIDI-CV, which we've been using to bring in control from an external keyboard. I'm not going to be using that in this video, so I'm going to just delete that to eliminate some of the clutter. And so here we are, and you can already see this gate light here is flashing on and off to show how the different beats are being triggered. And actually you can see down here as well that as each beat is triggered, the green light below it flashes very briefly on to show that that's been triggered. So we have 3 rows of controls, and you can see 3 different outputs here, row 1, row 2, and row 3. So I'm going to go ahead and hook up row 1 to my volts per octave. This is what I used to have hooked up to the input coming from my keyboard from that MIDI CV module, but now it's being controlled by the step sequencer. And before I even do that, I'll go ahead and just hook this up very briefly into the signal scope so we can see what this looks like. Right now, it's just showing a constant 0 signal, but if I move one of these knobs up a little bit, see that when we get to step 4, it briefly goes up and then back down. And say step 5 maybe goes up even higher, and then we'll see that go up higher, and so on, before it goes back down. So that's visually just showing you what this is sending out, these changes in the signal when we hit these different steps in the sequencer. But right now I'm going to hook that back up to volts per octave so it'll control the frequency of my voltage controlled oscillator, of my main oscillator. And then this gate, I'm going to use that to trigger my ADSR envelope, just as I was using the gate from the MIDI CV module before to send a gate every time I pushed a key down. Now it's coming from the sequencer. And you can immediately hear this general low pitch is happening most of the time, but then it's going up at these places where I change the knobs. And I can change these all to whatever I might want. So I've got all my sounds coming through here with 8 different frequencies being triggered by the 8 different steps. And this is a good chance to show you some more general controls you have. I can turn off the run button here. And so then the sequencer will stop running. It won't send anything else out until I turn it back on again. I can push reset. That'll just jump it back to step 1 right away. I can change my clock speed so that the steps come faster or slower. Make them really fast or really slow. Go back to the default here. I can also turn on or off particular steps by pressing these green buttons down here. So maybe I only want half of them to play. Or maybe I want to turn all of them back on. And then I can also control the number of steps. So right now it's at using all 8, but if I take this down, then it'll only do the first 4 or the first 2 and so on. I'll go back up to all 8 though for now. So that's the basics of how it works, and I'm using that to control frequency right now. But let's do something with row 2 as well. Maybe for row 2, I can disconnect the ADSR from controlling my low-pass filter frequency, control that with row 2 instead. I'll turn this up a little bit higher to start, but then here we can start running this again. These are all at 0, so my low-pass filter frequency is really low right now. It's not letting anything through, so I'm not hearing much of anything. But if I start turning these up, I'll start to hear some sounds, and those timbres will get brighter, letting more frequencies come through the higher I turn that knob for a particular beat. And then maybe I want row 3 to control this knob I keep moving back and forth on the mixer, the overall volume of the sound. So I can just hook row 3 up straight to my CV. Again, these are all set to 0 right now, so I'm not getting any sound through because it's just sending them to silence. If I start turning these up, I'll get different amplitudes coming through for each one. I can turn that overall level up as well. Okay, let me stop running that for now. And I want to show you one more thing, because I don't know how you feel about the sounds there, but I thought they were pretty awful. And one of the reasons that they're awful has to do with the frequency content of what we're listening to. And so to address that, we need to quantize the frequency data that's coming out of row 1. So let me explain briefly what that means. We're already quantizing time. In other words, we're kind of rounding time to the nearest beat here. No changes are happening outside of these 8 regular pulses. So we're always getting this sense of meter, of this regular kind of pulse to what's happening. What we need to do is do the same thing to quantize the frequencies that we have, because right now this knob goes continuously from a minimum to a maximum value, but that's not really the way that our sense of pitch works, or the way that we do musical scales. If you think about the notes on a keyboard, we play a note and then another one, and there's all kinds of kind of glissando or kind of microtonal space in between those notes, which I'm kind of accidentally playing those in between spaces by moving these knobs to arbitrary places. So to be able to make sure that those round off to the nearest place, I want to quantize them to the nearest pitch that matches something that I would see on a musical keyboard. And we're going to add one more object in here, the Quantize object, or QNT, to help us do that. So back in Rack, I'm going to go ahead and press Enter. I'm in my VCV section. I'm going to pick that QNT, or quantizer object. And I'll just put that right next to my VCO here. And what I'll do here is right now, row 1 is going straight into volts per octave. Instead of that, I'm going to have row 1 go to the input of my quantizer, and then the output of the quantizer will go to volts per octave. And you should already hear a difference now. It sounds like it's in tune now. It doesn't sound like it's out of tune anymore. And what's really nice now is that I can actually pick which notes in my scale I want to keep. So I can turn on and off different notes here by just clicking on them. So now I've only got one note left. And now I've got 2 and 3 and 4 and 5 and so on. This can really sound nice, in particular if I ramp up the clock speed. Really get kind of a big general texture here. Even faster if I want. Turning different notes on and off. To kind of get different harmonies coming through. So by adding this simple object in, what I'm able to do is have a lot of control all of a sudden over the pitch content. Not only tune it to a traditional scale, but actually choose which notes within that scale I want it to be able to round up or down to. So that's the basics of how we do quantization, and also the basics of how we do step sequencing. So to wrap up, in this video, we've looked at how we make loops of events at steady time intervals, at steady pulses or beats, using a step sequencer, and how we can use that to control anything we want, the same way that we used envelopes and LFOs to control anything we wanted before. Just in this case, it's with a slightly different structure of this rigid timing and these discrete triggers of things. And then we also looked at this notion of quantization, how a step sequencer enables us to quantize events in time, but how we can also use the Quantize or QNT module to quantize events in terms of pitch content, to quantize them to a scale or to notes within a scale. In the next video, we're going to try to bring together all the things we've learned in these first 4 videos and make a much bigger patch that makes some more interesting and complex sounds, bringing together all the different elements that we've used to date.